Iron meteorites point to millions of years to chaos in early chaos in early solar system. Meteorites provide clues about some of the violent events that took place in the early solar system. A great uh, demo demolition debris debris with a chaotic mass of 8 asteroids and forming planets consistently slamming into each other took place in early solar system between 7.8 million and 11.1 million years after the sun formed. According to an analysis of iron meteorites that were once part of metallic asteroid cores, an international team of researchers analyzed isotopes of palladium, silver and platinum in 18 iron meteorites found on Earth to better understand the evolution of their parents' bodies. Metallic asteroids contain dense iron cores, and iron meteorites originate to form these cores, blessed by of collision with other asteroids. Palladium 107 undergoes radioactive decay into silver 107 with the half-life of 6.5 million years. Previous measurement of the relative abundance of two isotopes by a mass spectrometer have already suggested that the asteroids cores that have been meteorites were once part of cooled rapidly. The question was, when did this rapid cooling occur? Platinum that originate from cosmic rays impacting the meteorite while the traveling through space. Our traditional measurements of platinum isotope abundance allowing us to correct the silver isotope measurements for distribution caused by cosmic irradiation of samples in space. The Hunt said in a statement. So we were able to delete the timing of the collision were precisely then even before. This that Hunt team arrived at were between 7.8 million and 7.8 million and 11.1 million after the formation of solar system. A relative short time span in its 4.5 billion years history. Although studying other meteorites might lighten the era, finding suggestion that the Earth's solar system was extremely chaotic. The planet would not have been finished forming an asteroid, and petroplanets would have been collide frequently, stripping the silicate metals away from some of the larger asteroids to expose their metallic core to space and allowing them to cool rapidly before further collision. The smashed to core apart. Everything seems to have been smashing together at that time, the Hunt said. Something caused this chaos, and Hunt's team think it was largely related to the dissipation of the solar nebula. It could be gas that formed the sun. Then the remnants of the cloud settled into a disk around the young star. As the gas cooled, dust and ice condenses out of it, which through the process is called acceleration, built up in the planet, asteroid and comets that we are familiar with today. But planets have only finite time to assemble. As the sun gradually switching on, the solar winds begin blowing away the remains the solar nebula. Young planet bodies have been meshed by refraction with the gases slowing their orbit velocity. Without the gases is the restraining these planetary bodies, there must be have the period of chaos in which the planet with Ramak leading to fury of collision. Exploration later coming down, the researcher explained. However, other events around the same time also have been contributed to the chaos. The team noticed the gas giant planets, in particular Jupiter and Saturn, migrated around the early solar systems, and their gravitational influence disturbed into smaller bodies. Us heading team there the asteroid belt and the Kuiper belt. One's model in particular known as the Grand Track, the posterior to Jupiter migration in system as the close to the Sun as Mars is today. Before Saturn's gravity influenced Jupiter to migrate onward again its present opposition. The Gantt track model predicts that the average would have to take about 10 million years into the history of solar system, providing what went on 4.5 billion years ago. However, this is challenge. This is new study suggesting that the fate of asteroids that produce iron meteorites provides new evidence of just how violent the early solar system could be. More information may come to light when NASA FASIS mission, which launched later in this year, arrived at the metallic asteroid Phakies in 2026. The research was published online May 23 in Journal Nature Astronomy. Keith Cooper is a freelance science journalist and editor in United Kingdom, and he has degree in physics and astronomy from University of Manchester. He is the author of The Complex Paradox: Challenging Our Astronomy in Research for the Extraordinary Intelligence, and has written articles on astronomy, space physics, and astrobiology for the Magnitude of magazine and